Assalamualaikum dear students and friends. So in today's video we'll talk about lapping zone in columns, which is very important for civil engineers and site supervisor which works on different sites and in different projects. So you should have to know about lapping zone in columns. Let's say I am drawing the longitudinal cross section of a column. Let's say this is a column, you can see here. So this is a column, so you can divide this column into three portions. This one L by 4 portion, the bottom side L by 4, I am making it L by 4, and here this is the, let's say this is the top side of the column, let's say this is the slab, so this is also L by 4 portion. This is also the L by 4 portion, so I am making it a hatched line just like that, and this also a hatched line like this. The overall length of the column is L. Let's say this overall length of the column is length L. The portion remaining is L by 2. This one portion is L by 2. So these are the three portions of this column. So now I'll name it just like this L by 4 portion and this L by 4 portion. These of the column are in tension zone. These are the tension zones. Tension zone 1, let's say, and this is also the tension zone. These two are the tension zones, and this one is the, let's say I'll hatch it with this ball point just like this to differentiate these two portions. This one portion is called the compression zone. This one is the compression zone. So these are the two portions. This one is the tension zone and this one is also the tension zone, which are L by 4 and L by 4, and this one L by 2 distance on this portion, which is the middle section of the column. This is the compression zone. So these are the three portions of the column, and the lapping zone is which portion? This L by 2. You can also say it is the compression zone. So here you will give the, we can also call it the lapping zone, compression zone. So you should have to give the lap in this portion. Let's consider it an example. Let's say we have a length of this L is 2400 mm. So where will you give overlap of this beam? So 600, you will lift 600 from this side and 600 from this side. This portion will become 600 if you divide it by 4, and this portion will also be 600 in mm. So you should have to give overlap after this 600 and before this 600. You should have to give overlap in this zone. So this will be the lapping zone for you in this column. Sorry, I'll hatch it like this, and this will be the lapping zone for this column, which is the compression zone. So for civil engineers and site supervisors, you should have to know about this zone, that how it is you can calculate it. You'll calculate the overall length by 4, you'll lift this portion, and you'll calculate the L by 4 and you'll leave this portion, and the remaining portion you will give overlap in this portion. So this is how you can calculate your calculations inside. Thank you.